Hi, I'm Ajmal. In this video, I'll be demonstrating how to solve an initial value problem using Euler's method. And, and this is the equation. So first, let's start by understanding how Euler's method works using a simple diagram. We are given differential equation like dy over dx equals to fxy. And we also given the starting point, for example, when x equals to 0, y equals to 1. That means the curve passes through the point 0, 1. At that point, we can calculate the slope using the function fxy. So we draw a tangent line. Now, since we don't know the full curve, we use the tangent to take a small step forward and estimate the next point. For example, so let's say we take next step to x1, step size is h. So if we go up, we can see that it touches the tangent line, which is closer to the actual graph. So we call that as y1. So you get a right angle triangle here. From this, you can try to find the change in y. How? Because using the rise over run formula. This is the rise, this is the run, h is the run. And you also know the slope, which is fx0, y0. So put together, you can get the rise h times fx0, y0. So to find y1, we get y0 plus h times the slope x0, y0. So you go on to do the same thing for the next step and so on until you get the curve. So the general formula will be yn equals to yn minus 1 plus h times f xn minus 1 yn minus 1. And that's all, you get the formula already. Now we can use this formula in the spreadsheet to solve the equation. Now I'll demonstrate how to apply Euler's method in Excel to solve the IVP. I've chosen a step size of h equals to 0.1. In my spreadsheet, I use three columns, one for x, y, and to find the value of the slope. So for the first column, I use this formula xn minus 1 plus h. So xn minus 1, which refers to the previous x value, which is c5 plus my h step. I use the dollar sign because I want to make sure my h value stay consistent throughout the x column. Then for the y, I use this formula yn minus 1 plus h step size times the value of the slope. So yn minus 1 is the previous y, d phi plus my h step times e phi, which is the value of the slope. Next, to find the value of the slope, I use this formula x squared plus 1 over y. So c6, the current value of x squared plus 1 divided by the current value of y. After I put the three formulas, I'll now select them, select three columns, and drag them to x equals to 1. Now I will get the y value, which is 1.91138. So these are our numerical approximation using Euler's method. Now let's compare this result with the exact solution. So I use general solution method to solve the equation. So these are the steps. First step is multiply both sides by y and separate the variables, y to the left side and x to the right side, and then integrate both sides. I will get half y squared, 1/3 x cubed plus x plus c. Then solve for y by multiplying both sides by 2. I will get y equals to square root 2 to x cubed plus 2x plus c prime. After I will apply initial condition and I will get c prime equals to 1. Then I will substitute it to the general solution to get yx equals to square root 2 to x cubed plus 2x plus 1. After I will sub x equals to 1 to the general solution to get the y value, to find the y, and I will get 1.915. Now I will compare it with Euler's estimate solution. This absolute error between Euler's estimate and the exact solution is about 0.00362. This means Euler's method was only off by a very small amount. To express this as a percentage, I use relative error and I get 0.90%, which is less than 1%, which shows that Euler's method with step size of 0, 1 gives a very accurate result. Thank you so much for watching this video.